Assalamualaikum warahmatullahi wabarakatuh. We are from TSP3B from Group 9. So today we are going to present Chapter 7 under topic Haloalkanes. Before we start, let me introduce you our group members. First, my name is NURLIYANA binti IZDIHAR and my group members are NAJLA binti NAMAZI and TUNKU Teja Jewa binti TUNKU MOHAMMED SUFRIZAL. Let's move to the first part. Task 1. Synthesis and reaction of organic compound. Look at the starting material given in the question, which is 1/3 butyl, 1 cyclohexane. This compound will undergo reaction of hydrohalogenation with catalyst. The condition and catalyst that we need are hydrogen bromide and dimethyl peroxide. The formation of compound A will follow anti-Markovnikov rule. So, compound A formed from this reaction is 1-bromo 2/3 butyl cyclohexane. Next, compound A will undergo nucleophilic substitution with potassium hydroxide. The 1-bromo 2/3 butyl cyclohexane can undergo hydrolysis with aqueous potassium hydroxide under reflux to form compound B. So, we need to break the bond at the Br and attach it with OH. Thus, the compound B formed is 2/3 butyl cyclohexane 1-ol. Moving to the next part, compound A will react with excess ammonia to form compound C. The nucleophile is ammonia. In this reaction, cyano will be substituted by amino group, which is NH2. So the compound C will form is 2/3 butyl cyclohexane 1-amine, which is also primary amine. In addition, compound A also can react with potassium cyanide in presence of ethanol and heat. The nucleophile is Cn, so the product formed is 1/3 butyl to cyanocyclohexane. Next, compound D can undergo nucleophilic substitution in the presence of lithium aluminum hydride, ether, and hydronium to form compound E. So, compound E formed is 1/2 butyl cyclohexyl 1-methylamine, which is also primary amine. Last but not least, compound D also can undergo hydrolysis in the presence of acid sulfuric and heat to form compound F. So, the compound F is 2/3 butyl cyclohexane 1-carboxylic acid. Next, the structure given in the equation, which is 1/3 butyl 1-cyclohexane, will undergo halogenation in inert solvent. The condition and reagent that we need is bromine, carbon tetrachloride, and dark to form compound G. The type of this reaction is electrophilic substitution. So, the compound G formed is 1,2-dibromo 1/3 butyl cyclohexane.
So, moving on to the next part, which is synthesis and reactions of organic compounds. First question, suggest a reagent and condition to produce compound A from suitable alkene and give the structure of alkene used. So, for this chemical reaction, we use Br2 as reagent and the condition is in UV, and we use 1/3 butyl cyclohexane as alkene. This is the structure of alkene used. Next question, show the reaction mechanism if compound A undergoes SN1 reaction to produce compound B. So for this reaction, compound A will react with KOH aqueous and reflux to produce compound B. The compound A for this chemical reaction is 1-bromo 2/3 butyl cyclohexane and will undergo the SN1 reaction to produce 2/3 butyl cyclohexane 1-ol. Next part is mechanism. The mechanism requires two steps. The first step is the formation of carbocation. As we can see here, the starting material is 1-bromo 2/3 butyl cyclohexane. And the red arrow here shows that the bond between carbocation and bromine will break heterolytically. This is due to bromine is more electronegative than carbocation that is more electropositive. So the bromine here will attract all the bonding electron to itself, in which cause the bond between carbocation and bromine to break. So since this reaction involves bond breaking, so the reaction rate for this reaction is low, and it will form 1/3 butyl cyclohexane and bromide. Step 2 is nucleophilic attack on the carbocation. Carbocation will react with nucleophilic and the nucleophile used in the reaction is OH minus. So the carbocation will react with OH minus. As you can see the red arrow here, it shows that the nucleophilic will be attacked by the carbocation and the OH will be attached to the carbon and will form two third butyl cyclohexane 1-ol. And the rate of reaction for this reaction is fast because it involves of making a new bond.
So now I'm going to explain task 2. For task 2, we have to find a plant or fruit that's related to our functional group, which is haloalkane, and the plant or fruit must be mentioned in the Quran. So the plant that we chose is seaweed, or to be specific, the Laminaria species. Seaweed is mentioned in Surah Abasa, verse 25 to 31 as further.
أنا صببنا الماء صبا ثم شققنا الأرض شقا فأنبتنا فيها حبا وعنبا وقضبا وزيتونا ونخلا وحدائق غلبا وفاكهة وأبا.
The meaning of the verse is how we pour down water in abundance, then crack the soil open, and grow in it grains, and grapes and herbs, and olives and dates, and luscious garden, and fruits and fodder. One of the chemical components that is contained in Laminaria species is 1-iodopentane. 1-iodopentane is a part of haloalkane functional group as it is an alkane and contains halogen substituent. As you can see, this is the structure of 1-iodopentane, and 1-iodopentane is the IUPAC name. This is the composition of Laminaria species. It has 0.68% fat, 55.8% carbohydrate, 9.12% protein, 25.4% ash. Laminaria species offer us humans a lot of benefits. For example, Laminaria contains iodine, which is an element that is needed by humans' body to produce thyroid hormones. It is also a rich source of iron and potassium. Laminaria is also used as medicine for some people. It is used in the cervix to end pregnancy, or also known as abortion. Other than that, Laminaria also helps in weight loss and reducing high blood pressure. It is also used as a bulk laxative for constipation, treating radiation sickness, and prevent cancer. This is the chemical reaction that can occur with the component. It will undergo nucleophilic substitution. The starting material for this reaction is 1-iodopentane. 1-iodopentane will react with KOH aqueous reflux. The product that will be formed is pentanol. As we can see here, the I is replaced with OH.
The last part, reference. We use Al-Quran, book and website to do our assignment. That's all from us. Thank you.